Hello everyone, my name is Alberto Rodriguez Guadarrama. I'm going to present my work with the time synthesis of the thin sulfide nanoparticle-decorated carbon nanofiber membrane as anode of the sodium batteries by a smart process. In this work, we developed an easy and eco-friendly method for the synthesis of the thin sulfide nanoparticle encapsulated in carbon nanofiber by electrospinning method. Carbon nanofiber members with the thin sulfide is a viable option for the development of the anode of the sodium batteries, since they can improve sodium diffusion, increase the electron-electrode interface, and reduce the risk of the contact between metal collector and the mix of the materials. For example, carbon nanofiber membrane with thin sulfide, sodium alginate, and carbon black. For the position of the carbon nanofiber membrane with tin sulfide, first PVP and tin chloride were dissolved in 10 ml of the mixing solution and the methyl formide and the methyl sulfide. Polymer solution was stirred for 18 hours until obtained homogeneous solution. Then, polymer solution was transferred to glass cylinder of the electrospinning system. The synthesis conditions were as follows: a distance of 12 cm between the cylinder and the collector. Voltage of 17 kV and a flow rate of 0.5 ml for hours. Thereafter, polymer nanofibers were stabilized at 250 Celsius for 2 hours in air and the carbonation at 800 Celsius on unattended atmosphere for 3 with a heating rate of 5 Celsius per minute. Finally, carbon nanofiber membrane with thin sulfide were characterized by using physicochemical analysis and electrochemical measures. The results figure 1 shows the same microphase of the carbon nanofiber membrane with tin sulfide, which have a morphology like a long streak with a diameter distribution about 120 nanometers. Figure 2 element mapping of the carbon nanofiber membrane with tin sulfide, the homogeneous distribution of tin, sulfur, nitrogen, oxygen, chloride, and carbon among the carbon nanofibers. On the other hand, nitrogen, sulfide, and oxygen doping have been reported to be beneficial to sodium ions absorption for the electrical reaction, and the presence of the elements in the composition would be advantageous for sodium ion storage. EDA result of the carbon nanofiber membrane with tin sulfide confirmed the presence of the oxygen, chlorine, nitrogen, carbon, sulfur, and tin on the carbon nanofiber sulfide. In addition, the minimum amount the tin and sulfur for the formation tin sulfide you can see table 1. The figure 3 shows the array partners of the carbon nanofibers and carbon nanofiber membrane with tin sulfide after carbonation at 800 Celsius. The carbon nanofibers had a broad peak between 2 theta squared 20 degrees to 30 degrees, which corresponded to 200 plane of the graphite. However, its structure predominantly amorphous. Modern world carbon nanofiber membrane tin sulfide show 5 different peaks at 2 theta squared 27 degrees, 31.50 degrees, 39.32 degrees, 44.50 degrees, and 51.08 degrees, which can be signed to 0 to 1 111, 041, 141, and 122 plan respectively, correspond to Herzenbergite. Figure 4 shows the cyclic voltammetry curves of the carbon nanofiber powder with tin sulfide and carbon nanofiber membrane tin sulfide. The presence of the tin sulfide phase and ether atoms in membrane promotes multiple store mechanisms of the sodium ions, such as conversion reaction, alloy, and intercalation. However, the powder of the carbon nanofiber with tin sulfide didn't present reduction and oxidation peaks corresponding to the conversion, alloying, and intercalation of tin sulfide because it loses the ability to absorb sodium ions in this structure. Other hand, the electrical impedance shows that the carbon nanofiber membrane with tin sulfide electrode has a lower resistance compared to pulverized, which improves the transfer of electrons in batteries. In conclusions, the carbon nanofiber membrane with tin sulfide by a simple electrospinning technique and sequence cancellation based on the physical-chemical characterization shows the formation of the tin sulfide nanospheres on the surface of the carbon nanofibers. In addition, over the surface of the nanofibers, nitrogen, oxygen, and chlorine are also uniformly distributed therein. The presence of the tin sulfide phase on and the atoms promotes multiple storage mechanics of the sodium ions such as conversion reaction and ion intercalation. Interrogate the carbon nanofiber membrane with tin sulfide is expected to have a high specific capacity. On the other hand, the electrochemical impedance shows that the carbon nanofiber membrane tin sulfide electrode has a lower resistance compared to pulverized. These merits make the carbon nanofiber membrane tin sulfide expected to be the anode material candidate for the high-performance sodium-ion batteries. Finally, the author wants to take for final FISA support for Canadian Mexican trouble the Great CB 2016 18 28 16 1 16. In addition, LRG thanks to Canasi for the postgraduate scholarship and Master Sergio Rodriguez Arias and PhD Marta Elena Rivas Aguilar for ERD and FSM measures respectively.